I hinted earlier that logarithms are just another way of writing exponents. So the first part that I have here is the formula on how to convert back and forth. Now what I'm going to show you though is there's a really easy pattern to switch between exponential form and logarithmic form. So first of all, why is it called exponential? It's because it has exponents. Why is it called logarithmic? Because it says the word logging. Very simple and easy to remember. So if I start off with something that has exponential form, it looks like this. So it looks something like that. B to the x power is equal to y. And I want to convert it to a log form. It's a very simple conversion because all you really do is take the x and the y and switch them, and then write a big log on the left. That's how simple it is. Now, if you notice over here, there's a couple things I want to point out. Oh, God. I do too. Okay. So things I want to point out is going from exponential to logarithmic, the x and the y, they just switch. That's all that happens. Now, if you look at where the b is at, the b kind of drops down so it's lower. It's no longer like, they use b, by the way, because it's the base of the exponent. But it's not on the same level as the log, the y, or the x. It's kind of like a subscript. You know, like an exponent is a superscript. Exponents are up. A subscript is down. So that b is down. Also, when you go back and forth between the two, you have to distinguish between things that are exponents and things that are not. So on this one, on the exponential form, you have to make sure that the x is actually up and smaller than the rest of it. Over here, this, and this, they're all the same size, and then the b is the small one that's a little bit lower. So our first goal is to just convert back and forth. So converting to exponential. Exponential means write it with an exponent. So the easiest way that I can show you how to do this is you basically drop the log and make the 10 big, and then take these two things and just switch them. So when that 3 comes back over here, it becomes the exponent, and then the 1,000 comes the answer. And if you check to verify this in the calculator, this is all true. And that's why you're allowed to convert back and forth. You can switch back and forth between logarithmic and exponential because they're equal. It doesn't matter if you have exponents. I mean, not exponents. It doesn't matter if you have fractions. Fractions work the same exact way. So if we're going to go from a log to exponential, we take off the log, the base gets bigger, we increase the size of it, and then we just take the two things that are here and here and switch them. So that -2 comes up as the exponent, and then the 1/25th is the answer here. Which, if you checked in the calculator, if you remember anything from semester 1, if you have a negative exponent, don't we flip it? Right? To make it to a positive exponent. And after you flip it, the 5 squared is now at the bottom, so that's how you end up with 1/25. So that checks out also. That's why we're allowed to switch back and forth. I'm going to show you one more, and then I want you to try one. So to get from log to exponential, cross out the log, bring the 10 down, and then switch the other two numbers. 0 goes up, 1 goes over here. And again, that's true. Anything to the 0 power is going to give you 1. 10 to the 0 is 1, so it's perfect. So I'm going to give you like 20 seconds to do the fourth one. Does anyone have an answer yet? What do we put first? Okay, 1/4, regular size, right? And then? -3 is the exponent. Equals 64. Perfect. There's your answer. The second part of this is to go the other way. So it says right here, in exercises 5 through 8, rewrite the equation in logarithmic form. So we want it to now be in log form, so it's got to say log. And then that 12, that becomes the little number on the subscript of the log. And then these two things, they just switch. So we put the 144 here, and we put the 2 right here. And look at the size of the stuff. The 144 and the 2, they're all the same size as the word log now. The only thing that's like shrunken down is the 12 and the subscript for the base. And again, I don't care if it has exponents, you do it all the same way. So we write log, because it wants it in logarithmic form, so it has to say log. The 20, this 20 right here, is the 20 that comes down here. And then this and this, they just switch each other. So I put 1/20th here, and then -1 right there. I'll give you like 30 seconds to do the next 2. Give it a shot, see if you can do it. Okay, I'm going to throw out the 2 answers real quick, see if you can check to see if you did it right. So the number 7 should say log base 216, 6 equals 1/3. That should be the answer to number 7. Number 8 should be log base 4, 1 equals 0. So all we're doing is really just switching that number and that number right there. How many of you got both of those right? Yes. So pretty straightforward, right? The test, that's your first 4 questions. That's what you have to do on the test. Just convert it. Now, hopefully you have a calculator in front of you, because that's what the next part is about. On the next page, there is a fact that I need to give you. And it's because of the way the calculator is kind of set up. So do me a favor on your calculator, hit the log button. Find the log button and hit the log button. What does it say when you hit the log button? Yeah, it just says this, right? Well, if you guys remember all of the problems that we did over here, they weren't just logs. They were like log base 10, log base, I can't see it, log base 5, log base 10, log base 1/4. Well, when we use that button on the calculator, it leaves it blank right here. Well, I'm going to give you a fact right now. It's called the common log. If you have just a regular plain log and you leave that spot blank, it means it's a 10. So in the calculator, if we were going to compute some of these things in the calculator, and that's not a 10, we can't use that button. So there's another way to access it. Now, before I show you how to do that, I want to show you just real quick how to do some of these without a calculator. But remember, guys, when we do our tests, there's no way I can tell that you did it with a calculator or without a calculator. I don't hold your test and be like, wait a second, this kid used the calculator. I can't tell. But I'm going to show you how to do it by hand, just in case there's one of those like problems where someone else did it and you have to like look through their work to see what they did wrong. So this is how you do it. Watch this. If you want to do this without a calculator, just set it equal to x. Then what you can do is you can convert it to the other form. So I'm going to tell you this as a sort of a heads up. The reason we need to change back and forth is for when we're stuck. When we solve equations later, we're going to get to a point where we're stuck, and changing the form helps. It makes it a lot easier to solve. So right now we're kind of stuck, so we're going to change forms. What would this be in exponential form? What would go first? The 9 would go first, and then it goes up to the x right there, and then this equals 81. So can't you tell me what x is now? 9 to the what power gives you 81? Yes, that just means x equals 2. how you could do it by hand. But what I'd like to do is I'd like to show you how to just do it in the calculator. So in the calculator, we're going to go into that menu into just the regular calculator mode. Now we cannot use the log button because it's log base 10, and the problem that we want to do is log base 4. So here's how you access the change of base formula. Well, it's not a formula, but it's the way the calculator lets you change the base. You're going to go into the math option, which is F4. Once you're in F4, there's one that says log AB, which is F2. Then it gives you the 2 boxes you need. So I put in the 4 at the bottom, and I put in the 2 inside parentheses. And notice it gave me the parentheses. On this log button that we're using right now, it's always going to put parentheses right there. So that equals 0.5, which we all know is 1/2, but I'll just write it as 0.5. The next one, type that one in. So you can see that the log AB option is still there. You don't have to hit F4 again, so you just hit F2, and then you can put in the 8 and the 1, and then execute gives you 0. And again, guys, the whole reason why this is happening is because of the conversion. This problem really says 8 to the what power gives me 1. The only thing that could give me 1 and be an exponent is going to be 0. Now, there are some problems that aren't as obvious, like the next one, for example. The next one would be 27 to the what power gives me 3. I think for most people, if you were further in this class, you would understand and quickly note that the only way to put an exponent and make a number shrink is to make it a fraction. If you just type it in the calculator, though, the calculator tells you it's 0.33333 forever, so that just means it's 1/3. I don't care how you put it, 0.3, whatever, I don't care. It's all the same to me. So just, again, if you ever use the regular log button, it's going to make it automatically as a log base 10, but you will never see the 10. So if you see a question on your assignment where it just says log of 27, use this button, log, and then just hit 27 after it and hit execute. But if it says log base 2, that's when you have to go into F4, and then you have to go into F2 so that it says log with the box down here and then the box up here. And that's pretty much it. That's your introduction to logs. So what the heck are logs? Logs are just a different way of writing things that have exponents. So you need to know how to convert back and forth between the 2 forms. And then it says to do it without a calculator, but it's the same thing. Just type it in, whatever. I'm okay with that. And so I'm gonna hand out the packet. You're gonna do 1 through 25, and it's due before you leave class today.